All right, so number 30. It says in the diagram below, triangle ABC and XYZ are graphed. The question is, use the properties of rigid motions to explain why those triangles are congruent. So they're telling us what to do, explain why triangle ABC is congruent to triangle XYZ, and they're telling us how we have to do it. We have to use properties of rigid motions, and that's big idea number 40. So the rigid motions are translation, which is the slide, reflection, which is the flip, and rotation, which is the spin, all of which preserve size, which makes them rigid. So you want to keep it simple. You just want to say, how can I get this triangle to map onto the other triangle in the most simplest way? So I think the simplest way that I see is to do a rotation of about 180 degrees. So we're going to do a 90 degree to the right and then another 90 degree to the right. That will be 180 degrees. So now, and if you do it about the origin, it will spin into quadrant quadrant 2, and then it will spin into quadrant 3. Oops, sorry about that. So we can say that these triangles have to be congruent because look, I can get that first triangle, ABC, to map directly onto X, Y, Z. So A, right, my first letter will map onto X. Right, A spins all the way down to X, and B does the same thing. B will map onto Y over here. And the transformation I used was a rotation. So this is, like I said, let's keep it simple. You can say triangle ABC is congruent to triangle XYZ because a rotation of 180 degrees about the origin, direction doesn't matter, I can go clockwise or counterclockwise, will map triangle ABC onto triangle XYZ. And that's it. I've used my rigid transformation to explain why they're congruent. Right? That mapping justifies the congruent statement. So if you buy that, you can stop right here. Just going to say a couple extra words to enhance this video. Jerome had while we were taking this exam, I noticed Jerome came up with a different solution. Jerome was going to say, look, I could take triangle ABC and I could reflect it over the x-axis, all right? And the danger in doing reflections is that the orientation changes. And if you answered this question by saying, look, I'm going to reflect about this line y equals negative x, yes, it does map on to the other triangle, but it doesn't do it in the order they request. They need A to land on X. All right, the first letter to the first letter. So if you reflect just once across the line y equals X, you're going to get this wrong. I mean, you'll get partial credit, but A will map onto Y, which is not what they want. So that reflection's wrong. And when I saw Jerome writing up his solution, I was, going to explain that to him, and then he persisted and he told me, well, look, I'm going to reflect over the x-axis. So C prime will be here, A prime will be there, and B prime will be there. And then, right, so we have a reflection about the x-axis. And then I'm going to reflect over the y-axis. And when he reflects over the y-axis, yeah, A double prime lands on X, which is what they needed. C double prime lands on Z, which is what they wanted. And B double prime will land on Y. So he's absolutely right. You could write it up as a reflection over the x-axis followed by a reflection over the y-axis, or vice versa, y-axis and x-axis. Two reflections will get you to map on perfectly. In fact, that rotation of 180 degrees is a consequence of these two reflections. They're like interchangeable. They're equal to each other. So just wanted to highlight another solution that was totally valid and presented by a student.